Hey guys, welcome to our last video for this unit on radical functions, graphs, and now equations. We're going to be looking today at how to solve radical equations. And it turns out that there are actually a couple different methods that we can use. So one is called the algebraic method of solving radical equations. The other one is called graphical. We're going to look at both of these and how you can use one method to confirm the other. So solving algebraically, think about how you would normally solve a math problem if you're given a variable, right? You would try to use opposite operations to move things away from that variable from the left hand to the right hand side of an equation, for example. You want to isolate that variable, right? Left, right side of an equation, move everything away from the variable that you're given by opposite operations. If you're going to do this method, you'll always want to double check your answers or your solutions in this context because sometimes your answers could be extraneous, so watch out for that. In some cases, we're going to encounter fraction exponents. We'll just have to remember something from a unit way long ago. That just means a radical, right? If I have a fraction exponent, we'll see an example of this later, it just means that we have a type of root and we'll have to think about what the opposite of that root will be. And the opposite of roots are exponents. So, for example, the opposite of a square root is a square, opposite of a cube root is a cube, opposite of a fourth root is a fourth power. That's something that we're going to have to think about when we're undoing operations, when we're moving or getting rid of something from one side of an equation to the other. Even roots, like square roots, cannot equal negative numbers. That's something that we'll encounter as well. And then lastly, for solving algebraically, sometimes we do have to factor. If we ever end up with an x squared, while we're simplifying, we will need to factor our problem, solving by factoring. So if you need to go back to an old video for that, I'm going to leave you to do that. The other method of solving that we can use is called the graphical method of solving. So what we would want to do here, okay, equations have, as we said, a left side and a right side. We want to graph each side individually by setting each side individually equal to y. So we'll see an example in a second about how that looks. But the point is that you'll end up with two graphs, right? You'll end up with a graph of the left side and a graph of the right side. If the graphs intersect, that means you have at least one solution. If they intersect more than once, you'll have multiple solutions. We'll see that in later units. But in this case, if they intersect, there's going to be a solution at the x coordinate where they intersect or they cross. If the graphs don't intersect at all, there won't be any solution. So let's take a look at an example of solving a radical equation by both methods, okay, algebraically and graphically. So we're going to start with the algebraic method. We're going to look at how we could use opposite operations to get x by itself. In this case, it would be on the left side of our equation. So we need to start moving things over towards the right. Right? Now currently we are adding by a 15 off to the side of this radical, so that's one thing we're going to have to move. Okay? So we want to do the opposite of that, and in this case that means subtract by 15 to both sides. Right? 15 minus 15 cancels out. Now we have something a little bit more simple on the left hand side of this equation, which is good. We're starting to get x by itself. On the right side, 7 minus 15 is negative 8. Now you could really just stop here and see there can't be a solution to this problem. Square roots cannot equal negative numbers, right? If I ask what's the square root of 0, you'd say 0. Square root of 1 is 1. Square root of 9 is 3. These are all positive numbers or 0. Even something like the square root of negative 9 does not equal negative 3. Remember, that would equal 3i. Square roots never equal a negative number. This is impossible. There's no solution to this. Okay? Now we could continue to try to solve this. For example, the opposite of a square root is a square. Okay, so let's see where this leads us. Opposite of a square is a square, so that cancels out our radical, which is what our goal would be normally. Gives us x plus 3 comes out from underneath that radical. Okay? Negative 8 times itself is positive 64, and subtract by 3. This looks like it should be an answer, right? X equals 61. Looks like it should be a solution. However, if you take 61 and you plug it back into your original problem here, just look at this visually. right? I have 15 plus a square root equals a lower number than 15. That doesn't make sense, right? This is what's called an extraneous or extra solution. It does not count. Okay? It does not balance both sides of the equation that we're given. So you could have just stopped when we saw that the square root equals a negative. Can't be true. 2 can't equal 3, right? There's some situations in math where an equation cannot possibly balance. This is one of them. Graphically now, how we could also determine that this does not have a solution is by taking a look at the right-hand side of our initial problem, which is y equals 7, and graph how that looks. How that's going to look is going to be a horizontal line crossing the y-axis at 7. Okay. If we graph the left-hand side, right, 15 plus, this was the right hand. The left-hand side was y equals 15 plus the square root of x plus 3. If we graph this, okay, on the same graph but on a separate line, right, these graphs will not cross. This is how this graph will look. It heads up towards the right, it increases. These paths never cross. These graphs never cross. And therefore, there's also not any solution to this problem. These graphs have to cross or intersect in order for there to be a solution. So, graphically, algebraically, those are both ways that you can see that there is no solution to this equation. So let's take a look at another example where we do have a solution. And once again, try to solve this algebraically, then graphically. So in this case, we have a square root on both sides of an equation. So what we're going to want to do is the opposite of a square root, square both sides. Okay, and what that does is it gets rid of the radical, right? We're trying to get x by itself, and currently we have an x on both sides. We're going to have to do something about that. But notice there's this 3 in front of the square root. Now, while the radical will go away, right, and you'll end up with 2x minus 5, that 3, use the power rule here, you need to square that 3 for it to become a 9 in order to simplify correctly. Okay. The things underneath the radical, right, those numbers come out from underneath it. That 3 was never underneath that radical, so you need to square it. Now we can proceed to simplify like normal. Multiply here or distribute. We end up with 18x minus 45 on one side, 11x plus 4 on the other. Okay. If we move variables to one side and numbers to the other, so let's say I wanted to, I don't know, move numbers over to the left. It doesn't matter which way you move your numbers or your variables as long as they end up on opposite sides. So I have a variable, I'm going to move to the right, and I have a number, I'm going to move to the left. I'm going to add 45. Okay, that moves the number away from the right-hand side, it moves it to the left, so 49. And so I need to move that 11x over to the other side. I need to subtract, in this case by 11x. That's the opposite of a positive 11x. Cancels that out. We get 49 equals 18 minus 11, 7x. Opposite of multiply is divide. Again, continue with those opposite operations. We get x equals 7. Now, I'm going to let you do this on your own, but if you do plug 7 back into x on both sides of the equation, both sides will balance. I believe in this case, both sides will equal 9. So you can confirm that on your own. But this does actually end up being a solution, okay, algebraically, but also graphically this ends up as a solution. If I take a look at the graph of what happens when I take y equal to the square root of 11x plus 4, that left-hand side, and y equals 3 times the square root of 2x minus 5. What's going to end up happening is you'll have a graph that looks something like, I don't know, like this. And the graphs will cross when x equals 7. This will be like 7 comma something. I believe it's 7 comma 9. But at any rate, that's what we see here. Okay? We do have a solution. These graphs do cross paths. They do intersect, unlike our previous example, and that means they do have a solution at the point of intersection, wherever that x coordinate is, in this case, 7. So, all right, let's do a couple more examples. Let's do one that involves something other than a square root, actually. So we see here, we're going to be looking at a fourth root. Okay. Remember, if we have a fraction exponent, think of how roots are like tree roots. They go on the bottom of a tree. This is the same thing as this. Okay. That fraction exponent means we have a root, a fourth root. So just like the opposite of a square root is a square both sides, in this case we have a fourth root. The opposite of that is a fourth power. Take the fourth power to both sides. Okay. Once again, what does that do? It gets rid of the radical so that you're enabled to get x by itself. In this case, on the left-hand side, we want to move things away. We want to move all those numbers away. 5 times 5 times 5 times 5. It's not 5 times 4. Be careful. 5 times itself 4 times. It's going to be a big number. 625, in fact. That's a very big number, but that's okay. Nothing wrong with that. We end up with 4x equals 600. If we divide by 4 at the very end, we find x equals 150. Now once again, if you plug that back into your original problem, double check that both sides balance or equal. They will. But one thing I want to point out here is that if you try to graph the left and right hand side, the graphs will intersect, and they're going to intersect when x is 150. So try to imagine that, if you will. See if we can do that. But these graphs intersecting means they're going to intersect I don't know, way over here. In fact, if you're going to use Desmos, and as always I would recommend that, desmos.com/graphing, you're going to have to zoom out your page in order to see where they intersect. So make sure that sometimes it might not look like the graphs intersect or cross. They will if you zoom out. So careful note there. Make sure you zoom out. The graphs will intersect. There will be a little dot there at 150 comma something. Okay? Last example I want to do today is a real-world problem where we're trying to find, let's say for example, velocity. So V stands for velocity, F for force, R for radius, M for mass. If you have a problem where you're trying to find the velocity of an object and you're given all these other variables, right, like 16, 4, and 5, all you're really expected to do here is to plug those numbers into the variables that match. So we're looking for velocity in this case. We have not been given that. That's an unknown value. And therefore, let's go ahead and plug these numbers in. Okay. And mass shows up twice, so we're going to plug 4 in twice. And let's say that we want to end in radical form. Now, what you could do here is just type this into a calculator. It's going to give you a decimal. That's not really what we're looking for. Okay? We want you to be able to simplify to a very accurate number. So we're going to leave this in what's called radical form. If we're supposed to end up with a square root, so be it. We want to end not with a decimal, but in radical form. So how do we do that from here? Well, number one, we can see that 16, right, that force, can be square rooted evenly, right? It's a 4. Square root of 16 is 4, and I'm going to leave that 4 times 5 by itself. And 4 divided by 4, right, if we take that 16 out, it becomes a 4. This is going to cancel top and bottom. So all we're going to have to do now is think about our mass is 4, our radius is 5. Can we simplify this a little bit more? Yes. Now you can't square root of 5, but you can square root of 4. So you end up with 2 square roots of 5, and then velocity is usually represented in meters per second. That's radical form. That's where we have a square root at the end, simple as possible, right? Try to find perfect squares that you can take out. If you can take any out, great. If not, okay, we'll leave it in simplest radical form possible. But what if, for example, we were given everything except for a variable on the right-hand side? What if we have to move things from the right to the left? So for example, if we're given velocity here, okay, so velocity equals 4, and we're given mass and we're given radius, but we're not given the force. Notice that's missing. We don't know what F is. That means we're going to have to do opposite operations. We will have to solve algebraically in this case to see what we would get. Okay. And in this case, you'll see that this 6 down here is not inside the radical, is not inside the root. And because it's not inside the root, you have to do opposite operations here as well. Opposite of dividing by 6 is multiply by 6 to both sides. 6 times 4, both sides, so you can cancel the right side. Okay, 6 times 4 will be 24 equals, I'm going to simplify the square root a little bit. Okay. 12 times 6 is 72. Opposite of a square root is a square, so now we can square both sides. We're going to end up with a large number there. 24 squared is 576 equals F times 72. And lastly, of course, we want to get rid of that 72 by opposite operations. Divide by 72 to both sides. You'll end up with the force being 8 newtons. All you really need to be able to do at this point is double check that this is not extraneous. So in both cases, if you plug 2 square roots of 5 into V and then check, is that the same decimal as what you get over here? It will be. Okay. Make sure both sides balance. Same thing here. If you plug 8 into F in your original formula and simplify that right-hand side, does everything equal 6? Does everything equal that mass that you started with? Sorry, the velocity that you started with. Does everything equal 4? And yes, everything will balance on both sides. So make sure that you always double check your work. Graph when you can to double check that the points of intersection for the left and the right side match that x coordinate that you should be getting when you're solving algebraically. And that does it for this unit. So that's everything about radical functions and graphs and so forth that you need to know, transformations. We will have a test coming up, and I'll see you for our next unit.